How y'all doing? Today we're looking at a scenario that came up on Backdoor from HackTheBox. And basically we have a directory traversal that allows us to read files off the file system. And what we need to do is get the command line for all the processes running on the system. So we're going to write a batch loop, basically, that loops over all of /proc, and then a number, and then CMD line, and grab all those and print them out, right? And when I solved it originally, I wrote this in a bash loop. It took about 6 minutes to do 2,000 PIDs, and I got what I needed and I moved on. But I wasn't really happy with that. I wanted to come back and see if I could make that go faster. So in this video, we're going to look at 4 different scripts. We'll take a quick look at the original bash loop. We'll then look at making that asynchronous and take something that runs in 6.5 minutes down to like 6 seconds. We'll then write a Python synchronous loop, and it'll actually take about the exact amount of time that the bash one did, 6.5 minutes. And then we'll delve into Python async programming, which I'm not an expert in, but I found a nice example template that we'll kind of copy from. And we'll do the Python async version. And again, I get that one to run in just like 4 seconds. So with that, we'll go ahead and dive in and take a look. All right, let's go ahead and get started here. So I've got in here the script that I used in my write-up when I originally did it, which is just going to simply do a loop over, in this case, I got it set for the first 2,000 ports. It's going to create the path, which is going to be /proc/ the port number / command line. It's going to figure out the amount it needs to skip. The way this directory traversal vulnerability works is it prints out this full path 3 times back to back. So effectively, I want to skip that length, this is how you do a length in bash, times 3 plus 1 to get to the next character. And then I need to remove the last 32 characters off the end. So I simply then do curl here. I replace the null characters with spaces. I then, cut off the beginning, reverse it, cut off the end, reverse it, and if there's still output left, I print it. And that works pretty nicely. Let's see, I can do a boot like that. And let's see, actually, I can do time like that and let this run, and we can get a baseline for about how long this takes. I'm going to go ahead and pause the video here, and we can pick up once this completes. All right, and we're back. So it took about 6.5 minutes here. Found a bunch of different processes running, some MySQL stuff. For the sake of this video, doesn't really matter what we found. We found a bunch of stuff. But in fact, 6.5 minutes is a long time. And the other thing is, I don't want to just really look at the first 2,000 PIDs. I want to look at up to 50,000, or there could be way more than that. So, and I don't really want to wait hours to do this. So I wanted to look into how to do this in a more parallel way, because basically right now I'm sending a request with curl. I'm waiting a half a second to a second for it to come back. I'm then processing it and quickly getting to the next one. And that's a lot of waiting. Why can't I send all those curl requests out and then process them as they come back? And so the way we're going to do that in bash, real easy. We're just going to remove this for loop and move it down here. And we're going to come up here and make this a function. So we'll say like, we'll call this like check PID like this, put a curly in front of it, and then we'll come down here and close curly like that. And now the one thing we need to do is, so anything we pass into this function, it's going to be $1 like that. So that's going to be the first argument of the function. The rest of this doesn't have to change because it's going to build the path. The path is going to get passed in here, etc. And so what we can do now to start, just as a first show, I'll show you what we want to do is we want to just start with, we'll call check PID on I like that. And we will use the ampersand to background it. And so effectively what we're going to do is we're just going to start, this loop is going to start check PID in the background, and then it's going to keep going, and it's going to keep going. Now this actually produces a little bit messy. Like we can't really actually time this. Oh, I didn't mean to save this in the same file name. I guess I'll clean that up later. So if I run this, what's actually going to happen, I think, is that time is actually going to return. As you see how time returns, the whole script returns, and all this stuff starts turning back. So you can tell it's way faster. I'm getting stuff really quickly here. But it's kind of messy because like what happens is it starts 2,000 processes, 2,000 calls to this function, and then it returns and the script's done. And this stuff's all just kind of going on in the background and printing out still, even though technically I have my terminal back, right? So that's kind of ugly. So what I'd like to do to clean that up, it's not hard, is we just come to here and put a new line, and we create something called PID, and we make it an array of, so for like I there equals, and then the $bang gives us the PID of the previous process. So we're going to get the PID of this thing. We're going to save it in this array. And then we just come down here and we do another for PID in $curly PIDs. And we put a star there to get all of them. Like that. Now we can do. We just call wait on PID. And so it doesn't really matter what order these all return, but basically this script, the overall script I'm running isn't going to finish until all the PIDs have reported that they're done. So if I save that and run this again, you can see this is going to start coming back pretty quickly. And we're going to see, did it mess up again? Huh. That's not what I expected. We'll have to go back and look at that for a second. I'm not sure why it's printing the, why it finished. How did it finish there? For PID in PIDs, do wait $PID. Done. That is strange. I didn't expect that to come back so quickly. Let's see if anything weird is going on here. Or I wonder if I didn't write it. That could easily be the problem. Let's try this one more time. Zoom out on this so we can see it. And I'm actually, yep, that was the problem. I just didn't save the file. So you can see right there, in 5.6 seconds, we made it through all 2000 PIDs. Now, they come back a little bit out of order, or sometimes a lot out of order, but again, I got the same stuff here. I could do this, because I'm doing this so quickly, I can even run this again, and I can pass it into sort. I don't know if that's going to work or not. I've not tried this, but let's give it a shot. Sort is going to actually end up caching all the output and spitting out at the end. But yeah, here we go. So now we have a sorted list. Oh, actually, it's sorted. So you can see 1, 0 actually comes before 1 colon. So I could probably do a sort by like -n for number. I'm not going to mess with that. You get the point, though. The point is, something that took 6 minutes before, I'm now doing in 5 or 6 seconds. And so that's super cool. That's definitely an interesting place to be. So I actually wanted to see, like, okay, well, what about Python? Can I do this in Python? And so to start, let's see, we'll come up here, let's get out of this. We'll do vim, boot process. Oh, I didn't mean to get out of that because I wanted to, okay, we're not gonna worry about it. I've got a copy, another copy somewhere else. We'll do group process.py. And so we're gonna start off with our shebang, user bin env python 3. We'll come down here. We're definitely going to need requests for the. First, we're going to start with just a synchronous version, and we'll do for I in range 1, 2001, like that, because we're trying to do the same range here because we're doing benchmarks. Response equals requests.get. Now I'm going to need to grab them brute.sh. Let's grab this here. That. I'm going to go ahead and make this an F string. And now we will do in here, we will do /proc /I /cmd line, like that. So that gives us the full thing we're trying to get a hold of, and that's actually all we need. We can do our same kind of thing as we did before. Start is going to equal, I'm going to do it slightly differently. Let's see. So we know, let's see, path is going to be proc. So 1, 2, 3, 4, 5, 6 plus the length of the number plus 7. Let's do this differently. We'll grab this. Come here. We'll echo this. Now we want to do -n, so there's no new line, and we'll get rid of this whole thing, and we'll type that into wc.c. So that's 14 characters. So we can exit here. So we have 14 characters plus the length of the string of I, like that. And that's going to be how long it is. Now that's going to show up 3 times. So we'll have 3 times like that. So that's going to be our start position. And I think we might need to add 1. I'm not sure, but we'll figure it out. End equals -32. Same as last time. Assume we skip 32 characters. CMD line equals response.text start to end, like that. And if CMD line, so if there's anything there, print And we'll do like a, well, let's see, how can we make this? We'll do I5, and then we'll do command line. And so when I'm doing F strings like this, all that's going to do is, so it's going to create a string where it's going to, have this I value colon space, the command line, and this colon 5 just means it's going to take up 5 spaces, so it's going to pad it. So it'll look a little pretty. So if we come down here and we do Python 3 root.py and we run this, let's see, new module name request. That's good because it's called requests. Oops. Try that again. You never get it right on the first try. And it's looking good. Oh, okay, so one thing I am missing here, let's go ahead and kill this for a second. If we go back up to this one, we did get rid of the null characters as well. So let's see if, I guess we can probably do it right in here. We can do dot replace \0. I think that will work. And then let's see, \0, and we'll place it with a space like that. Give that a try. Quit that and run this again. And ooh, let's see, F string can actually backsplash. Okay, we'll do this up here. Dot replace \null, or we can do ox00. I know that's a null. Space like that. And then we can get rid of this replace and just get command line. And we run this and we get, that's looking better. So you can see sbin init, auto, blah, blah, blah. I didn't put a time in front of this. I'm going to go ahead and just, for the sake of our benchmarking, we're going to go ahead and time this like so. And I will pause the video here and come back when that's done. All right, and we're back. And like, interestingly enough, this took, exactly, 6 minutes, 7 seconds is not that different than what the curl one took. It just kind of goes to show you that whether you're making curl or Python requests, it doesn't really matter. What's taking the time is the time it takes for the request to get out to the server and come back to you. So we're going to try to make this asynchronous as well. And I'm not great at async Python, but I found this article right here on Twilio, and they are giving this nice example right here where they are using the async, the AIO HTTP library kind of instead of requests to make asynchronous requests. They hit this API right here, gather a bunch of Pokemons, try to collect all of them here, Pokemon pun not intended, and then they loop over them and print them out here at the end. And so we're going to steal that same structure, move this off screen, but I'm definitely going to be referencing it, and make ourselves a Python script. So let's see, we'll do it, we'll work down here in the bottom for now. Oops, vim. Root process, we'll call it async.py. So just like before, we'll start with our shebang. Python 3. And now we're gonna, just like they do in that article, we'll import AIO HTTP, we'll import async IO, and we don't need to import time because we're not gonna time it. We'll time it on the outside. We'll do, again, just kind of like what they did. We will go ahead and start with our async defining the, we'll call it git process, right? So maybe someday I'm going to get smarter at this again and I can do an overview on Python async stuff. But for now, I'm going to say asynchronous functions start with the async keyword before the def. So we'll go with that. Process, we'll need to pass it a session, just like they do in the example. And in our case, we'll pass it a PID. We'll create our URL and they'll have that equal to an F string here. And we're going to grab it right out of here like this. And I called it PID, so we will call it, instead of we'll call it PID here as well. So now we can do an async with session.get URL as response. Again, I'm just kind of copying this out of the template that came over there. We'll do, just like we did above, we'll do start equals 3 times that length. We will do end equals -32. We'll do command line equals, and this is the little bit tricky part. My gut instinct, I was playing with this earlier to try to get it working. If you do response.text, that's what I would do in request. That doesn't work. It complains, oh, response.text is a method. So you do a little bit of reading the docs, and it says you need to add, it's a function, you got to call it. But you can't just call it. You actually have to await it. And again, this is another weird thing about, it looks unintuitive to me being used to doing the synchronous stuff. But for async, we're going to await this function, which basically says we're going to call this asynchronous function, and we're going to wait for the response to come back, and then we're going to continue to process it. And so we need to put that in parentheses, and then we can do our start to end here, just like that. And we'll do our replace here as well. Replace, place our nulls with spaces, and we should be good there. And then we can say if cmd line print f, and we'll just copy this from up here like that. Now that is pretty, so that's our get process function. Now we got to come down here and do another function. So we'll call async def main async, and again, I'm just pulling this from that article, AIO HTTP .client session as session. So that's the session object we're going to be playing with. Another thing that got me the first time I was doing this, I'm going to need to, even though, so in the Python one, or in this Pokemon example, they're collecting all the results in this task thing, and then they loop over, they await these tasks and they loop over them. And I thought, oh, I don't need that. I'm just going to print up here instead of returning. Well, it turns out that it doesn't like that. If you're going to do this async IO ensure future thing where you call this function, this is what sets it off running asynchronously as many as you can. You have to keep a list and gather them at the end here. So I'm going to go ahead here and we will do tasks equals like that, just define it. We can now do for I in range 1, 2001. And let's see, lost my thing there. Okay, and now we can do tasks.append. And then that's going to be async io.ensure future. And so ensure future is what's going to manage, kicking off all of these functions. We're going to into it, we're going to pass get process session and I. And that will look just, so we're going to call this function with the ensure future, which is going to run it asynchronously. So once we're done with that loop, we're going to come down here and we're going to await. It's going to say, I need all this to finish. Async io.gather tasks. And so that is going to say, wait till all of these things are done. And then, then I can be done. Now, I could, after this, do a loop. If I wanted to instead return the command line up here, maybe the command line on the pin, collect those together and print them out nice and in order or something, I could do that. But instead, I'm just going to call it there. So the last thing I need to do is do async io.run on main. Like that. So async io is going to run this main function, which is then going to kick off all these other ones. And it's going to work awesomely. I hope. Come up here. We will do time Python 3 root process async.py. See if I can get it right in the first try. Of course not. Invalid syntax. See, what did I do wrong? What line is it? 17? Async. Oh, I got to do with. It's just me not copying well out of my template that I'm copying. I is not defined. Oh, I bet I copied. So here, this is, for some reason we decided to call it PID this time, so we're going to need to know the length of PID. That's fine. That's a good sign we're getting into it. Somewhere else, I is not defined. Line 13. Oh, right here. PID. I should have just changed the variable to be called I, but and it's working here. And it's pretty good speed. And let's see what we get as far as times. 7 seconds. I don't remember what our bash one got. I don't know if we still have that handy. There's our 6 minutes. Do I have too many errors here to go back and find this? Might not be worth it. 6 seconds. I wonder if we could run it again and get roughly the same. So let's see, 4 seconds. So some of this is dependent on the load on my wire going out the house, etc. But anyway, you can see much faster than doing it synchronously. So anyway, I'm going to call it here. Hopefully this is interesting. I will, I think I'm going to make a blog post. It'll either be in the Backdoor write-up, or I'll create a separate blog post and put this video as well as some of the video, the 4 scripts, and some benchmarks. You know, what if I run this over, you know, if I run each of the 4 scripts over 2,000 PIDs, and then if I run the same thing over 50,000 PIDs, what do the times look like and how does it perform? So with that, I'm going to call the video, and I will talk to you next time. Thanks so much for sticking around till the end. Bye.